Thank you. Thank you very much. Welcome, Craft. Yeah, I selected that picture, which I have in the talk here for a reason, and this is my metaphor I currently use for distributed systems. So whenever you're building a distributed system, you probably build like microservices or functions or smaller like components, which are probably that small hut over there. So you can like close the door, you have a heating, you have transaction management, you know what your threads are doing, you're in one programming language, so it's a relatively cozy thing to do that within there. But whenever you open the door, then you're meeting that like rough ocean here, and that's the network. The network does tricky things, and it's probably slow, it's not available, it's probably available, probably not. And that actually poses a lot of new problems, which I think most people are not really aware of, to my, at least to what I see in the products, what I see in the market out there. There was quite an interesting observation on the InfoQ. You probably know InfoQ. They do a lot of good like articles and resources, and they did a trends report earlier this year. You can look it up, and it's freely available. And they said, okay, microservices late majority, so most of the people are probably doing microservices. Who is doing microservices here in the room? That's like 50% probably of the people. That's a lot. I mean, that changed a lot. So we're really moving towards that, and microservices are inherently distributed. But the fun part of that thing is correctly building distributed systems. That's early adopters. We don't understand what we're building there. That's kind of a challenge, right? I personally find that very funny, actually, but that's the motivation why we have to look into these kind of things much more. And I wrote an article about that beginning of last year, so this talk is based on that article. So if you want to read it up later on, there's a link. It's on InfoWorld, so you can just have a look at it. And basically, if we get going into the topic, if we have a system of, like, let's say, complexity in a certain extent, like really doing that in smaller pieces, like microservices, one thing we have to understand, we have to accept, is that parts of that systems are always broken. And that's really a mind shift. Like 10 years back, 15 years back, and even yesterday on a different conference, somebody asked me like, hey, can't we just like make it highly available, and then this component is always on? It just doesn't work anymore if you have like a big system. Even if that's like available 99.9999% of the time, and if you have like 100 components, you will have a time where not everything is up. We have to get used to that, and that's a mind shift. But the important thing, and that's what we have to learn now, is like we have to stop that from bringing down the whole system, from a rippling effect, like getting everything on fire. And that's about resiliency. And I make a very easy example. And I love this easy example because there you can already see that it's not that easy. Let's assume you build a payment service. You want to retrieve payment for whatever your company provides. And then you want to provide credit card. Oops. Oh, I'm back. So that's resilient, right? Something, it's not always working. That's what I mean. We have to accept that. And I want to provide credit card charges. I'm not doing credit card handling normally myself as a company. I use some service which is already available, probably even a SaaS service in the internet, something like Stripe or whatever. And I probably call that my REST service, right? Something I hope you can easily imagine. I want to jump in a bit of code actually in a minute. So for today, I chose Java. I'm not sure if that was a good decision. Who is like fluent in Java here in the room? Oh, wow, that's a lot of people. Spring Boot? Oh, the same people, interesting, okay. But so it's obviously a good choice, okay. Because I love actually showing concepts in code. The code I'm showing, it's on GitHub, so if you want to check it out, just go to my GitHub account, check it out, run it. It's all using open source components, so you can just directly like run it. Let's go over there. And yes, this is Eclipse, right. That's the most asked question actually afterwards. Why are you using Eclipse? Why not? So what I do here is I'm providing a REST API. That's easy, Spring Boot, right? So I'm just having a REST controller. I'm probably providing a REST API, like a put method in order to do payments. Then I do like all the good things, like a system out print line in order to show something. Do a couple of nonsense things here. That's not important, but the important part here is now I want to charge the credit card, and now I'm calling another REST service, right, in order to do that. How do I do that? In Spring, I'm using the REST template, doing a post, within URL. This URL is probably from some kind of registry. Sending over a request, which is like normally then like it's JSON, but I can provide that as Java object, get back a response, probably get some data from it, and that's it, right? So normally, most of you probably already have done something like that, right? So I have that running in the background. And if you're not in Java, in the back of your head, you can translate it to whatever, Node.js or Golang or C# or whatever. I have that running. So this is the service I've just showed you. I have a second service running, which is kind of a fake service for my Stripe handling, for the credit card handling. So I can do a couple of things with that. And then I have a REST client, so it's pretty easy to do something. So when I do that put request I showed you earlier, you will see my nice little sys out here. So I received the request, and this does a REST call on the other side. So far, it's probably not that amazing. The interesting thing starts when I do something like this. I can basically simulate that the credit card service is behaving slow. And that's also kind of a simulation for the network towards the service is slow. And that's quite a common situation. So the response is slower. You have latency, you have whatever, network hiccups and these kind of things. So it's now behaving slow. Interesting question now is, what happens if I hit the send button? It's actually too big of a crowd to really wait for an answer, so I'll give the answer myself. If I hit that, right, I'm going there. This, again, calls a REST service. This now takes, it's a random delay, 59 seconds. It could be that some HTTP timeout hits me, but it shouldn't actually with the 59 seconds. So what happens, you can see it here, the REST client is waiting. Here, we have one thread blocked, waiting for the response of that fake server. And that's actually pretty bad. Why is that so bad? We're now really moving one step towards this architecture. So we're probably saying, hey, we're having that credit card service here, it's broken or it's slow, we have to accept that, but now we have the payment service, and this now is waiting for the other one, and that means the threads are blocked, and the threads cannot get like new requests, and after a while all the threads are exhausted, and you cannot like take new requests, and then the next service is out of order or probably behaving slow, and so on and so forth. So that's a pretty bad situation to be in, so you shouldn't do that actually. There's an easy fix. Most people are aware of that easy fix. That's actually changing. So 2 years back, that was not a normal case. It starts to change. So if you don't know it yet, that would be at least one homework to look at, circuit breaking. Like there are frameworks around the pattern is circuit breaker. It works like the circuit breaker in your house. So if something is weird with the electricity, before the house burns down, it just switches off electricity, then it can fix things, you switch it on again. And this is how a circuit breaker works here as well. If something is weird with my REST connection, if it's like too slow or not responding or responding weird, it just switches off and probably not even like doing another request until it's really fixed. And there are frameworks. I'm using Hystrix. Hystrix is actually out of date by now, so you should be in Java. It should be Resilience for J or whatever. But there are frameworks in basically all languages available. What you can do now, if I charge my credit card, the code doesn't change much. So it's still there, but now I wrap it in my circuit breaker. Right? There are multiple ways of doing that, but I like that way because it's very transparent what happens. So I just wrap it in my circuit breaker, and that's now my V2, my version 2, and that behaves a bit different. So if I now do a REST call to V2, this one is still slow. What happens is that, okay, it's not that slow, but it's too slow, 3 seconds. What you can see, the behavior changes. On the left-hand side, you see the exception, the stack trace from Hystrix. If I scroll up, I see that somewhere Hystrix is involved. What you can see on the client side, it's not waiting, it's not blocked, it gets a 500. It gets an exception, so it's not possible, okay? That's an important pattern, actually, because you want to avoid this situation. So for me, that's kind of a basic pattern, actually. That's a circuit breaker. It's also very often known as something like fail fast, because you don't want to wait for all these timeouts to happen. You fail as fast as possible in order to move forward. What I now see in a lot of projects is that this is what they start to understand, but this is where they stop. And I think that's not a good idea. And in order to make that more transparent, in order to understand that better, I normally tell a short story. Who has used an airplane before? Yeah, right, most of the people, right. But that's good, you know the process, how that works, right? You book a ticket, and then normally 24 hours before the flight, you get an email invitation for check-in, right? Then you click on that check-in button, you select a seat and whatever, do a couple of things, confirm, then you're checked in, and the next thing you do normally is you press on a button to send the boarding pass, because you need a boarding pass at the airport to go through the security, right? And to go on the plane, obviously. I did that for a flight more or less 2 years back, I think. I flew from Germany to UK, in this case, to London, with Eurowings, and I could check in. That did work, right? I was checked in, but when I pressed that button, it says to me, hey, there was an error sending you the boarding pass. Okay, that's an exception. It's probably not nice, but okay. Let's look at that. As a disclaimer, we are not having Eurowings as a customer, but we have other customers which do, I would say, comparable things. So from what I know from them, I envision it like this, right? So I'm in front of the some kind of web UI, which basically does all the things for me to display that on my browser. This communicates with for example, microservice, which does the check-in, but this microservice doesn't do everything on its own, so it probably leverages other services in order to do that. So for example, something to generate the 3D barcode you have on the boarding pass, or generate a PDF if you want to print it out, or my personal favorite, if you fly British Airways, you can select to send it as a fax. Awesome. So that's probably another service, and so on and so forth, right? So there are a couple of services which you probably have to leverage. And my assumption is that the barcode generation didn't work, right? There are sometimes services which are not that reliable. But what I said earlier on, we have to accept that. There's not really a way around that. We can make it highly available so that doesn't happen too often, but at some point in time it will hit us. They had something in place that this didn't tear down the whole system, so the check-in was responding normally. So that was kind of okay. So that part of the whole situation, I don't have any problem with that. That might happen, right? The problem I have with that design is what they did with the arrow they have down there in the system. They basically transported it all the way up to me as a user through all the layers. So I saw that exception that something is really broken down there. And I consider that a better design, and I want to explain why. So the first question is, what do I do about that situation, right? That's the interesting part. It's totally obvious to like programmers, developers. You hit F5, you retry, of course, you try it again, because for us it's kind of logical that this does probably work. My wife is always like puzzled, like why should it work? It didn't work now, why should it work in a minute? Yeah, it does, just try it. But it didn't actually, it didn't work again. And then I did it, retried it 5 minutes later, didn't work. I got the same exception. And then what I did next is I said, okay, I tried again in a couple of hours. I increased the interval for retry. But then I know myself, so I forget these kind of things. So I had to remember that. And the way I did that was I entered a calendar entry in my Outlook to remind me to do that. And that's a pattern I call stateful retry. Right? I want to retry it, but I want to retry it later on, and therefore I have to remember it, so I have to persist that state that I still have to do it. And it's actually, in this case, it's really bad design that I, as a user, should do that. I mean, it's a boarding pass. I don't need it right away. I need it when I go to the airport. Like, whatever, an hour, 2 hours before the flight would be sufficient. So I don't think that's a really good design. The irony of that story was when I had, and it was really the same trip, when I had an onwards flight from London, and this time with EasyJet, I had exactly the same problem. That was actually one of the first triggers to do that kind of talk. But they're better actually in the error message. So what they say, and that's kind of awesome, okay, we're having some technical difficulties. Okay, we recognize that. Please log on again, so retry. If that doesn't work, please try again in 5 minutes, increase the interval. And actually the best thing, I love that, we do actively monitor our site, we'll be working to resolve the issue. There's no need to call, it's your problem, solve it yourself. We don't care, right? And it's, I mean, if you have it like this, like as an end user, as a consumer, it's very obvious that this is probably not the best way of solving that. But I see exactly that attitude all the time when you have microservice to microservice communication within the same company. And this is the same thing. It's still a bad pattern. You shouldn't just rethrow the exception like a hot potato because you can't handle it. It would be much better like, hey, we are having technical difficulties, but we sort it out. Don't worry. We send you the boarding pass right on time. Don't worry, right? That would be much better design, and it would mean that I do that stateful retry already in the component which is closest to it, which can resolve it, and that should be the check-in. The check-in should really do that, like until it's done, and not transport it further. When I discuss that with people, normally they start to get that, say, yeah, that would be probably a good idea, but now we have that stateful. Stateful is kind of an evil word, right, in 2019. Everything should be stateless and serverless and whatever. So state is kind of ugly, right? Yeah, so it means we have to handle state. That's for sure. There are a couple of ways of doing that. So the naive approach would be, I just store it somewhere, like in a database, for example, in a table, or whatever you have as an infrastructure, right? Just store, retry this, resend the boarding pass. The thing is, as soon as you do that, and a lot of people, a lot of projects sense that from the beginning, you have additional requirements. You have to do things like scheduling. You have to do the retry. You have to have a thread doing that. You have to have a scheduler doing that. You have to take care about exceptions happening because the scheduler has to be monitored. You have to have an operations tool probably where you can look at that. You have to think about, and that's actually one of the hardest things, about versioning. So if you change the procedure, how to send out like boarding passes, and you still have pending ones, you have to think about that situation. It's not always easy to resolve. So for me, there's a separate class of tools you can use for that, which is normally, it's a state machine. Normally, nowadays, they come as a workflow engine or workflow automation platform, all these kind of things. Whenever I propose this to people, then they start like, oh, this is this BPM from the past, the big vendor stuff, really proprietary things. I always call that death by properties panel. You have to click through a lot of things. I don't want to use that. I mean, I can't use that for REST calls, right? And that's not really true anymore. There's currently a lot of movement in the workflow engine market. I want to come back to that. But at that point in time, I always make that disclaimer. So like every human being is opinionated, I'm as well. So what's my background? I co-founded basically a workflow automation vendor, and we're doing an open source workflow automation platform. So I'm kind of biased for that. But on the other hand, I'm working with workflow engines, and I contributed to different open source engines over the last 15 years and did a lot of projects like globally for different customers. So I have quite some experience with that on the one hand. On the other hand, I mean, most of the problems I'm looking at through the lenses of state machines. That's probably good to know, right? Good. If you have any questions either later on, or here's my email address, here's my Twitter address, just shoot it over. But the market, that's what I said, is really, there's a lot of movement. So at the moment, you can look at the cloud vendors. All of them are doing kind of state machines, like AWS does step functions, Azure does durable functions, Google does Cloud Composer, and so on and so forth. If you look at the Silicon Valley stacks, and a lot of people in the microservice space are normally doing that, if it makes sense or not, Uber does something like Cadence, a workflow engine. Netflix started something like Conductors, a workflow engine. Airbnb did something like Apache Airflow. That's not really a workflow engine, but it's also a comparable problem. And there are a lot of open source ones, especially in the Java space, right? So you might want to look at that. For today's, yeah, right, and even at scale. I'm not talking about that today, but if you're interested in that, let me know or ask me later on. So you can also nowadays run workflow technology on a horizontal scale. So you can also do that for use cases where you have like 100K rate REST requests per second. That's doable. It's not like a slow technology anymore. But for today's demo, and I want to go back to the code that you get an understanding what I mean. I'm using the engine we do, that's an open source engine. But you can compare that to a couple of the others. So it's like, for me, it's more important that you get a feeling of what I mean with these kind of state machines and how I can apply that to this problem. So if I go back to my Eclipse, if I go back to my code, I can jump right back to version 3. How did that change? What I now do is I'm basically using a workflow engine here. So the Camunda engine. We have a Spring Boot starter, so it just added a dependency to that, and then I'm here. It uses, under the hood, it uses a data source, relational database to store things. That's provided by Spring, so it's relatively easy to get started. Then I can define a workflow definition. Talking about that in a second in more details, but for the moment, I just say, hey, I'm starting here right? The next thing I do is a so-called service task, so I do some logic. What I do, logic means, because I'm in Spring, I can attach a Spring Bean, so the Stripe adapter, that's just Spring expression language, resolves to a Spring Bean. In that Spring Bean, so in the Spring Bean, the code actually didn't change. So that's exactly the code you had in version 2. I just moved it to that separate bean so I can attach it to my workflow. Then the workflow is done. So what's the advantage? Hey, now I'm having a state machine. I can do things like, hey, if that fails, please do a retry with a time cycle of, and that's an ISO format, retry 3 times with a delay of period time 1 minute. But I can configure whatever I want. I could wait for 2 weeks if I want to. And then I deploy that, you get versioning and these kind of things. I'm not going into details here. And then the only difference here is if you charge the credit card, you don't do that right away, but you kick off a workflow instance doing that, right? And that's basically more or less it. So if I go back to that, I have my Stripe fixed server here, my payment here, go to V3. So the behavior changes again. And that's actually a very interesting thing. So if I do that, I have to click actually. I see that this takes too long. I see that the circuit breaker still switches off, so I get exception in my service. It will do a retry after a minute, so if I keep talking long enough, we see another exception coming through. But one thing that changed, and that's actually one of the interesting parts to look at, I changed the response code, right? So what I did is, I'm not anymore responding like in 200. 200 means, hey, here's your result. Or 500. 500 means, hey, here's your exception, it didn't work. 202 means, I got the request, I will do whatever I can in order to deliver that and talk to you back. So I'm starting to move towards asynchronicity, right? And that's actually an important thing to recognize here, and I'm going more deeply into that as well. In the background, there's now something going on. Like I can look into my workflow instance, which is currently going on here. So this, I normally use this, that people understand, hey, this is a state machine. It's now waiting in that activity to retry the REST call until it's probably done, or after the 3 retries, we get an exception, we get an incident, right? So these tools have kind of a monitoring for that normally. Right. When I'm at that point normally, when I discuss that with products, like, yeah, okay, that was kind of easy, that looks interesting, but now you change the response code to 200 to accept that. That's not what we want. We want to have a synchronous result. And I discuss that really often with IT folks, with business folks, so it's really, everybody involved is not really used to that thinking. That's what I see in the market. So assume you want to, for example, book a ticket. I'm actually not really sure about train tickets in Hungary, but in most of the countries I know or where I did that in the past, is like you select where you want to go, you select the exact train, you probably select a seat reservation, and at the very end, you provide your payment details like a credit card, and you like do book, and then you get a ticket like a PDF. It's still like that. I definitely know that for a couple of countries. And I discussed that with these companies, like, and they say, it has to be like that. We need the PDF right away. The person like behind the computer needs to print it out in the moment he books. And I'm not convinced that this is the best design, actually. The choice you have, if you think back and if you accept that some parts of the systems are always broken, it means there's a probability that this doesn't work, right? And you can actually, I know that from if your credit card is expired, you get an exception at the very end. And the thing is then, you have to redo the whole booking process. So if my decision is I get a synchronous error message or an asynchronous result later on, I'm sure what I would love as a user, right? So I would probably prefer this kind of asynchronicity. What actually makes sense for me, and I'm not walking you through the code is homework, it's on GitHub. So I have a version 4. What I can do there, looks the same, right? 202 accepted, exception here. Because the system is still unstable, right? My service here is slow. So if my system is basically back to normal, if everything is behaving fine and fast, then my version 4 goes back to 200 okay. So this is, I think this is a behavior I should probably aim for if I'm really REST-based. Get a synchronous response whenever possible. That probably might make sense. But if you don't get it, don't freak out. Have a plan B. Go for 202. Don't go for 500, right? So that's an interesting thing to think about. So what I did here is relatively easy. I now have my payment service. I basically added a small state machine, which is really persistent, so I can also like shut it down, pull it up again, and it will work. Relatively easy. Like architectural-wise, I'm not going into the details of that. So there's a blog post, there are a couple of things. But what I did here, I just embedded this workflow engine as a library in my Spring Boot application. If you're running other Java things, you might want to run that differently, like run the workflow engine as part of your container, that's possible. Or if you're not in Java, you're probably running that as a separate server and communicating with it, that's possible as well. So there are a couple of possibilities what you can do. If you're interested in that, read that later on. So I'm now basically did retrying, stateful retrying. And one thing I can promise you, if you do distributed systems, you will have retries. You will have that. Probably not stateful, but at least retries. It's hard to avoid retries, close to impossible. The thing is, if you do retries, what's really, really important on the other hand is making your services idempotent. Idempotent means if you get the same call twice, it doesn't harm your system. There are multiple ways of achieving that, but it's really important. And I give you an example again from the consumer perspective, because that's easier to get, but it's the same for service-to-service communication. Like if you want to book a ticket, for example, and I'm using flight examples all over the place nowadays, because I have so much of them. The good part of that talk is now, every time something goes wrong with flying, I'm kind of happy, hey, I get a new cool screenshot. This is one where I want to pay for the ticket, right? You know these loading bars, I guess, like loading, transactions, and progress. And this is also a bad design, like, hey, please do not close this window or select the back button on your browser. I want to select the back button. It's kind of like my evil brain wants to try what's happened, but I'm never doing it because it might cost me money. But that's a bad feeling, right? If you do that in a train or while traveling and you see a tunnel emerging, like the Wi-Fi is leaky, ooh, that gives me a bad feeling. It should be like, hey, you want to give us money? Awesome. We make sure that's convenient for you. We store some whatever trace ID locally, or we make sure it's idempotent. That's actually the sign you should aim for. That's my favorite slide. Took me quite a while. I had a vegan part of my life, so I tried to eat vegan. It was like 6 years back or something like that, for around 2 or 3 months. What I can already tell you, it doesn't work if you travel a lot. So, but my favorite dish was zucchini noodles. So there's a special slicer, you just slice the zucchini into noodles, then you add some sauce, awesome. I can totally recommend the dish, send me an email if you want to have the recipe. The good thing about that, it's called Vegan for Fit, there's a book, and it's also about like healthy food and these kind of things. It's written in there, you can eat as much as you want from that. It doesn't matter, you can eat literally as much as you want, also in the evening, because it's quite healthy. You don't grow fat, nothing. So I thought, hey, okay. So if you eat your plate of zucchini noodles and you forget about it, you can just eat another one. You forget about it, oh, you eat another one. It's totally idempotent to eat zucchini noodles, which is pretty different to pasta, right? And I know that's quite a silly metaphor. If you have a better one, I'm totally open for suggestions. That's the best I came up with so far. But for me, it's important that this sticks. So if you want to have like the single takeaway from this talk, idempotency is super important in distributed systems. I think it's one of the #1 problems you have if you call a service which is not idempotent. It's hard to get around that. Good. But we're not yet done. So let's assume you charge the credit card, you do the retrying, right? The other one is idempotent, so you don't charge the credit card multiple times. But at some point in time, you normally give up. You say, hey, this is not going to work. It's just not available. Then you probably raise something like, hey, the payment failed. I can't get the payment for you. Sorry, you have to cancel the order or whatever it is, right? The ugly characteristic of distributed systems is, or one ugly characteristic, when you do a call, a REST call, for example, you get a network exception. You have no idea which of these 3 situations just happened. It could be that the network was already broken when you tried to do the call, so it never reached the service provider. It probably reached the service provider, it started doing things for you, then it exploded, and you have no idea if it just committed the transaction or not. If it did everything correctly and the response got lost, you get the same exception. You have no idea what happened. You can't know. You can do the same exercise with messaging. You send out a message, don't get a response back, you have no idea. Could have happened, could have not. And there are situations where you can ignore this, but payment is a good example where you probably shouldn't. Customers are not that happy if you just like, hey, you didn't pay, so you don't get the order, but you charged me. Probably not idempotently, you charged me 10 times. That's not a good position to be in. So you have to think about it. What's the solution? That really depends a bit on the API and the service you want to call, but it could be that you at least have to make sure you cancel the charge or you check if something was charged. It really depends on the service. But the important thing is you have to think about it. You have to do it. And that's with the first REST call, for example. And if that service was not very reliable when you called it the first time, that's why you gave up. It's probably not that reliable when you want to clean up. So again, this should be stateful. This should be like really durable. It should be reliable. What I'm using here, by the way, like for these kind of models, that's called BPMN, Business Process Model and Notation. I know that this like BPM thing is not like really sexy for developers. It was like kind of a hype like 5 or 10 years back. But I really like that language. So that's a language to express these kind of flows. It's an ISO standard, so it's really widespread worldwide. It's mature. You can express a lot of things. I have a couple of other examples, especially for distributed systems or these kind of enterprise integration patterns. If you know that book, you can express a lot of things with BPMN. And it's easy to understand, so I haven't explained to you a lot of the pictures, and I hope you got it. And it's not only for developers. It's also for, like, yeah, of course, business folks, like discussing requirements. That's obvious, but the important thing there is also like we're getting a lot of problems, which I just talked about, like the retrying or whatever, because of technical things. The network might be leaky, but the reaction to that is a business decision. What should we do? Do we have to clean up? How long should we retry? So we have to discuss these kind of things with business people, with the requirements folks. That's on the one hand, but that's more obvious. And for me, more important sometimes is the operations part. So we have operations people which probably see, hey, there's an exception there. There are 317 instances stuck in the charging the credit card. Let's look into that. Let's understand it. Let's fix it. And they're probably not developers. And that might really help to get something. And you get a lot of statistics and whatever. Right. Good. So far, we talked a lot about synchronous communication, like REST. That's still actually my personal statistics. So whenever I ask, it's like 70–80% of the people are still doing a lot of REST in the architecture. You probably also want to go for asynchronicity. From my perspective, it makes a lot of sense to at least think about that. So messaging and these kind of things. If you do that, actually, it doesn't change that much on this level. So then you don't call the barcode generation via REST API, but you send over a message and wait for the response. What could happen? The response probably never arrives. And then it's the same thing. You shouldn't have the user waiting for his boarding pass saying, hey, it didn't arrive, I have to click again. You should recognize that in the check-in service, and therefore you have to wait for the response and you have to monitor that, right? You have to have timeouts probably. And this very quickly is more than milliseconds, and then you start to be probably stateful again. And this you can, for example, express again in BPMN in these kind of flow languages. Hey, I send out the message to generate the barcode, wait for the response. If that doesn't happen within a certain time frame, I resend it. There are small things like the dotted line here means, or the dashed line, I do that in parallel. So I keep waiting, send a new message, right? Relatively easy to do. It's stateful again, it's persistent. What you can do also is like, you can have more advanced logic, something like wherever I am here in the process currently, if it's too late, I do plan B, whatever plan B is. I know it from, I have a screenshot from Virgin Atlantic. They sent me really a text on my mobile. We have problems with your check-in, please go to the counter. So that's not totally unrealistic. The important thing is to think about these kind of things. Who uses a message bus here? Keep your hands up, please. Yeah, that's 20, 30%. That's pretty. Keep your hands up for a second. Who has no problems operating the message bus? It's pretty dark. 1, 2, 3, 4. That's more than usual. Usually it's 1 or 2. At one point in time, I thought he follows me around the conferences just to raise the hand. I'm the one. But it's surprising. I mean, it's surprising. In 2019, messaging is not a new technology, and I think it's an important concept. If I try it on an architecture on a whiteboard, messaging makes totally sense. If I start using it, I get problems, especially around dead messages. That's what I see at all the customers. Like, if you can't, if you get a message and you execute on that, and you get an exception, you don't have a client where you can throw it to. So you probably retry, and after a while it gets a dead message. And the dead message normally goes to a dead letter queue, and then an operator has to look at it, because he has to understand what to do with it. What else could you do, right? You could ignore it, probably not a good strategy. So, and this is hard. There's not good tooling for that, because then the operator has to understand, how did the message end up there? What's the payload? Probably he wants to fix the payload, resend the message. There's no good tooling for that. It's hard to understand what's happening there. So most of the customers are building something like what they often call homegrown message hospitals, like in order to fix that. And that's kind of weird, right? And one observation I had in the past, so one thing, I hope that gets better in the near future, but you still have one problem. Normally, this kind of tooling really focuses on one message. So you have no idea where this came from and what's next. So it's still, as an operation person, it's hard to understand why the message ended up there, right? What I saw a couple of customers doing, and that's pretty interesting. So what we did earlier on is we had that service where we call the REST API via the Java code. You hopefully remember, like 20 minutes back. You could use the same logic in order to put a message in a queue. That's what I call a push model. So you push that towards the other service. What you could do instead, and Workflow Engine support that, is you can fetch work from the Workflow Engine, so a pull model. So you could say, hey, there's this service. I can do that, and we use a topic name for that, so it's comparable to PubSub from messaging. I could do that, fetch the work, and do it. And if you use that, what you could do is you could use something like a Workflow Engine even for task distribution between services. I'm not proposing that as best practice architecture. I don't want to, but I at least observed that a lot of customers are doing that. And then, for example, service B knows I can do whatever B. That's kind of a topic name. It subscribes to the Workflow Engine, and B is defined in some workflow, and as soon as the workflow arrives there, it does it, right? So it's not like B doesn't have to know about the workflow from A, but it just knows what it can do. It's kind of a topic, kind of a queue. Interesting architecture. Good. We quickly skip that to last topic. 3 minutes for distributed transactions for consistency. That's actually one of my favorite topics, but we do it in 3 minutes. That's fine. So what I'm talking about here is I want to do 2 things in an all or nothing semantics. So either everything happens or none of it happens. What we did, like if you're in that one hut, like in one microservice, you can use transactions for that, like begin transaction, rollback, or commit, right? The thing is, now we're in that distributed system. And in distributed system, there was an idea like 2-phase commit, 3-phase commit, distributed transactions, XA transactions, whatever you want to call them. So the idea was, hey, we can do the same in this distributed system. No, you can't. I don't have the time to explain you the details of that. A good read is Life Beyond Distributed Transactions from Pat Helland. Pat Helland worked at Amazon at the time. Now he's at Salesforce. He writes really good papers, and he explains why distributed transactions aren't a really bad idea. And that's, they're too complex, they don't scale, people don't understand it, so there are a couple of reasons for that. So you don't have distributed transactions, but you still have the requirement, I want to do 2 things in all or nothing semantics. And you have to think about that very differently in distributed systems. Yeah, right, so because you don't use distributed transactions. And one approach, not the only one, but one approach you could do is very often referred to as the saga pattern. And the saga basically means I make sure it's consistent at the very end. Yeah, right? But I might be inconsistent in the middle. And it means that, for example, here I still charge my credit card. And we learned that's a REST call, so that's not transactional. Probably the credit card charging, it's transactional on its own, right? But I can't do a joint transaction. So this is one REST call I do with its own local transaction. And then I probably, before I do that, I want to look on if the customer has any vouchers on his account, deduct that from it. That's another microservice. It has its local transaction, but I cannot do a joint transaction. And if the credit card now fails, I have to make sure to clean up. And cleaning up, that's what these kind of compensation, they call compensation activities, are for. So I want to really do a semantical undo of what I did before, right? And that's what BPMN, for example, can express with these rewind symbols. So I really just say here at the very end, I want to now compensate, and that compensates all the activities which were executed in the past automatically. Workflow engines can do that, and again, reliable, and so on and so forth. So that's a pretty interesting use case again. Right, I'm having our own talk on that, not here, but it's recorded, it's in the web, so if you're interested in that, probably look that up. So, quick recap. So what I did in the client in order to basically avoid these pitfalls is timeouts for messaging, especially retries, stateful retries, and compensation. And very important, in order to be able to do that, service providers have to be idempotent, and they have to offer these compensation methods. That's what's a big showstopper if you work with legacy systems. And then you can kind of manage these kind of challenges, the 3 pitfalls. Good. If you're interested in more like event-driven approaches, in the same example, I also do a bigger example where I start working event-driven. I'm not talking about there today, just a hint. Go there if you're interested in that. So be aware of the complexity in distributed systems. It's not easy. Hopefully everybody knows, and know some strategies to handle it. Circuit breaking is important, but it's a basic thing. I think a lot of problems are really stateful, but that's probably my personal bias. Thank you very much.
Thank you so much. We have time for just a couple of questions. I love when speakers speed up at the end when they are done coming in. Micro-distributed system. Can we skip how do you highlight your present, please? What happens if the workflow engine is not available?
I mean, if the workflow engine is not available, it depends a bit on the architecture you choose. If the workflow engine is embedded, it's part of your service. So then normally it means either the service is available like overall or not at all. Because the workflow engine is just one library, it connects to the database, which you probably connect to anyhow. So that's nothing central in that way. You can run it in different ways. So if you run it as kind of a separate thing, and if it's not available, your service will probably not work. If it's a central infrastructure, same thing. But normally you don't run that as central infrastructure that often. And then same thing.
All right. Why use circuit breakers instead of proper timeout values?
The circuit breakers are quite powerful in what they can do. It's not just a timeout mechanism, but for example, they can also do things like, hey, this didn't work, so I switch off, but then after 100 requests or after a minute, I retry like one thing, and in between, I don't even do a request, for example, and these kind of things. And they write statistics about that, so you can even have a monitoring where you can see availability of the services you call. So there are a lot of things in there. Probably proper timeouts are something are still valuable on top, but I would definitely go for a circuit breaker additionally.
All right, and maybe the last one. How do you notify users later once their request is fulfilled successfully? You cannot send another response.
Right, so that's basically a question about the 202, I think. So I accept the request, so I have to send them a response later on. How do I do that? It depends, as always, on the architecture. So the typical ways are either the client with a 202 response gets some kind of ID, or you already have an ID, then he can ask, like polling. Just ask, hey, are you ready yet? Are you ready yet? That's a typical approach. Another approach would be you have a callback mechanism, like another REST call, or probably another back channel, like messaging. So these kind of things are normally,
All right. Thank you very much.
Thank you, guys.